Hi there. In this video, we'll learn about the risk analysis from the point of view of a firm, and we will also try to make sense of why risk analysis is an important thing in our long-term decision making of the managerial economics. So let's focus on the meaning and then the measurement of risk. We know that future is uncertain by its very nature. It is something which is a universal truth. So it holds for the managerial economist's analysis as well, because he has to deal with the firm, and firm is also vulnerable to the unexpected changes that can happen in future. And a managerial economist does not know the exact outcome of each possible course of action. There are a number of options that a managerial economist has, and in that situation, what are the outcomes? And knowing them exactly is something which is not possible. So that's where the uncertainty creeps in, and the risk analysis is necessary. So this is why we are going to study risk analysis. What is risk? In proper words, we can say that it's a kind of situation in which there is more than one possible outcome to a decision. So there is again the same thing that we mentioned earlier, that there are more than one possible outcomes of a decision or a step that we take, and the probability of each specific outcome is known or can be estimated. So if the outcomes are multiple, their probabilities should be known, or we may be able to estimate them by using some historical record or some scientific knowledge or tools, equipment. We can do this, and we can incorporate the probabilities for each of the specific outcomes. This is something we'll do as we go ahead. In such probabilities, these probabilities are usually unknown, but when they are not known, we can use the historical record or patterns, or we can use the scientific tools, just like we understood here. So this is why in this process of evaluation and comparing the investment projects, we use these concepts. These are three tools that we can use to assess the risk and uncertainty. If we start from the first one, it is known as the expected value, other is known as the standard deviation, and the third one is coefficient of variation. The good thing is that all three of these are based upon simple mathematical and statistical tools. So let us see how we can understand these three measures. The first one is expected value, and as we can see that it is an expected value, it means that there is a possibility of uncertainty or likeliness is there. And when we say likeliness or possibility, it means that there is a chance of having a probability as well. So here, the expected profit or value or return of a project is subject to the risk, and it is obtained by multiplying each possible outcome or profit from the project by its probability of occurrence, and then adding these products. So this is the detailed description of what we will do, but mathematically it becomes easier to understand when we see that expected profit or expected value is equal to the sum of the products of the possible outcomes of profit multiplied with their probabilities. So when we multiply these two values for each of the outcomes, where I is showing the outcomes, then we can add them. Once we add them, we get the overall value, that is the expected profit. And this bar is basically showing the average, because it is actually a sort of average. It's a weighted average, and the weights are equal to the probabilities. So it's a probability weighted average of the various possible outcomes of the profit. These lines basically tell us about the same things, and I have told you. You can pause the video and understand these. And for this, the interpretation will be as follows: that the investment projects facing equal risk, the firm will choose the project with the largest expected profits. So the largest expected profit should be the touchstone for selecting that certain project, and we will see this in numerical as well. Now the other measure is the standard deviation, and we all know that it's a very famous tool in the statistics and a basic one as well. And it is basically used to assess the absolute risk of any project. And what we can do is simply calculate the standard deviation, and that will be easy for us to do, because the standard deviation is actually the square root of sigma, that is the variance. sigma square, which is variance, and when we take the square root, it becomes sigma. That is the standard deviation. So here we are, the same thing that we have studied in basic statistics. However, we must pay attention to this, that is the probability weights and the individual outcome, and it is introduced with a minus sign after it, and we are going to subtract the expected profit from it, which is shown by pi bar. And when we do it for all possible outcomes, we get this sum, and then we take its square root. So again, this formula will be more clear once we come to the numerical example. And if we talk about the interpretation of this, it is basically showing that if the value is greater, it is showing greater dispersion of the profits of a project from the expected value. So it means that the greater this value, the more will be absolute risk in that certain project. Since we were talking about absolute risk, we can also calculate the relative risk, and for that we are going to use this formula. Before we go ahead, I just want to encourage you to subscribe to this channel if you haven't, and you may also click the bell icon so that you receive the latest notifications and videos. Now finally, coming to the final measure, this is the coefficient of variation. It is the relative dispersion of the possible outcomes of two or more projects. So here we are going to compare two or more projects on the basis of their risk, and this risk will be measured in a relative manner, that is, the relative dispersion will be calculated. And it is very easy because we simply have to use the already calculated value of standard deviation. We are going to divide it with the expected profits, and it will be equal to the coefficient of variation, which is represented with V-like letter, but this is not V, it is actually the upsilon, which is the Greek equivalent of V. And for this, the interpretation is relevant, that is, an investor will usually prefer a riskier project only if the expected profits is sufficiently higher than that of a less risky project. So it's quite justified that an investor should invest in a more risky or riskier project only if its expected profits is substantially or significantly higher or sufficiently higher, because it is expected profit, and if we are going to go for this riskier project, the returns should be substantially higher. Just like we say, the greater the risk, the greater the return. So if the return, the expected return is greater, then we can go for this riskier project. Otherwise, it will not be justified. Coefficient of variation can also be used to compare more than one projects. Now let's talk about the numericals. The first measure was expected value. We can do this with the help of this table, in which we actually have two investment projects, namely A and B. And in terms of the state of economy, there are three possibilities. One is the boom, other is the normal situation of the economy, and the third one is the recession. So these are the three possible states of the economy. And then we have the probability of the occurrence. It is also given, and this set of probability will be for the profits that the firms can earn under various situations or states of the economy, that is boom, normal state of the economy, or a recession of the economy. Now these products will be added as we will go ahead. We will see this numerically as well. This sum will be equal to 400. We have already mentioned this, and let us see how it will happen. This is the column of the state of economy, which can have these three states that we have talked about. This row or these rows are basically for the first project, that is project A, and this bunch of rows are for project B, and they are the same in terms of their headings. So states of economy will be the same because we are talking about the same economy. So if there is boom in the economy, it will be for project A as well as for project B. Both of the projects will be under the same state of the economy, since it's a macroeconomic phenomenon, these three states. And the probabilities associated with these states are also given 0.25, 0.5, 0.25, and again the same set of possibilities. And then we have various profits. If the economy is in boom, project A will earn us $500. If the economy is in a normal condition, project A will earn us $400. If the economy is in a recession, the project A will earn us $300. So you see, these are the three outcomes that are there with the project A. But we are going to multiply these profits with their probabilities, and you can see that it is happening here. This is expected value, that is 2 into 3, the second column, and the third column. So it will give us the fourth column. Here you can see 500 into 0.25, and we get $125. So this is the expected profit from project A. In case of a boom, in case of a recession, this will be the expected profit. But we know that we are talking about one value that should include all the possibilities, all three of them. So the first one, the first expected value is 125, the other one is 200, and then is 75. So let us add all these three values, and it will give us 400 as the overall value. That is the expected profit from project A, considering all the three possibilities of the state of the economy. So you can replicate the same thing for project B. Here the probabilities are the same, and the reason is simple, because the same economy is being considered, so the probabilities are the same as they are for project A. Now simply we can multiply these two values and we can get this, and the same with these two values and then this value, and these three values can be added in order to get the expected profit from project B. It is also equal to 400. So it is a coincidence, it is not necessary that the values of the two projects for their expected profits will always be the same. It is just a coincidence. So we will be indifferent between these two using the criterion of the expected profit. If there was a difference between the two values, definitely it would have become easier. For example, if it was 500, then project A would have been preferred. Now, project A has an expected profit value, project B has a project value for its profit, and it is the expected value. It is also 400. So both of the projects have the same expected profits. Now we can also understand by the depiction of these possibilities by using the probability distribution, which is yet another tool from statistics, and it's a very basic tool. This is the diagram of the probability distribution of these two projects for their profits. You can see project A, project B, both of them are plotted. There are two graphs. This is expected value profit. Again, it is the expected value profit. On x-axis we have profits, and on y-axis we have the probability of occurrence. So 600 is the amount of profit in case of a boom. This is for a normal economy, and this is for a recession. These are the associated probabilities. So this is probability distribution, which can help us to understand the same thing in a more depicted way. The other numerical is for standard deviation. We know that it's for absolute dispersion of the profits. Here the table will tell us that the standard deviation for the first project is this, and for the second project it is this. And let us see that how we can do this. Here is the state of economy. This is the deviation. This is the deviation squared, probability, and then the product of the probability with the deviation square. Now, boom, normal, recession, these are the three outcomes of the states of the economy, and the deviation can be easily calculated by considering the profit under boom, which was 500, minus the expected value profit, which was 400. Profit in the normal situation of the economy was 400 minus the expected value profit, which was again 400. Profit under the recession in the economy, it was 300, and the expected value profit was 400. So this is how these differences are calculated. These are the answers. These are the squares of the answers. Minus 100 will become 10,000, for example. And then the probabilities, they are mentioned again, and then the products of the deviation squared and the probabilities, we will get these values. Now this will be the variance, that is the products that we have calculated here, the squares of the deviations multiplied or weighted by their probabilities. This is equal to 5,000. For the standard deviation, we can calculate the square root of it, and here we have the answer, which is $70.71. For project B, you can pause the video and see the same kind of calculations. The answer of the standard deviation in this case will be $141.42. So now we have the comparison of the two, the project A has a smaller standard deviation as compared to that of project B. So it means that project A is having lesser absolute risk or dispersion in the risk. So we can go with the project A in this case if we are trying to mitigate the risk. Now, coefficient of variation is the third measure that we learned, and it is now easy to calculate it because it is going to calculate the same values that we have already calculated. We don't have to calculate anything new here. For project A, we have already calculated the standard deviations in the last process, and expected profits are also calculated, which were the same. And coefficient of variation can be calculated by the ratio of the two. Here, the formula is mentioned. Here the calculations are done. You can pause the video and see the simple calculations of the ratios. Now we have project A that has a smaller absolute risk than project B because it has a smaller value of the coefficient of variation. So of standard deviation in this case, because we are talking about the standard deviation and it's related to the absolute risk. We'll come to the coefficient of variation in this step, but before that, the expected profit shows that it is the same. So both of the projects are going to give us the expected profits in the same amount. And then the coefficient of variation that we were referring to, and we can see that the smaller value is with the project A, so it has lesser relative risk as compared to the project B. So here again, the project A is looking like to be more suitable even in the relative sense of the risk measurement. Here there's just a small caveat, and that is because 400 is the same, that is the expected profit is the same. So in the formula, if this value that is in the denominator, the value is the same, then the comparison becomes easy, and it can be done only on the basis of numerator because the denominator is the same. So this is the thing here. Otherwise, if we had different expected profits for the two projects, that is A and B project, then definitely the role of the expected profit, that is the term in the denominator, would have become more significant. So in the caveat, the same thing is mentioned. You can pause the video and read the caveat. Expected value can be used in a more elaborated way by incorporating a certain diagram, which is known as the Dcm tree. So let us see how we can use this Dcm tree in order to make more meaningful interpretations. So here we have a situation where firm manager is trying to make a decision that if he should go for a plant worth $2 million or $1 million. So this is the question that the firm manager has to answer. And here again, the three states of the economy are possible. That is boom, normal situation, and the recession. These possibilities are depicted in various sections, as I have mentioned them. This is the section 1 of the figure that tells us about the amount that one is likely to invest in this firm. That is $2 million plant or $1 million plant. So this is the first section of the diagram. Second section of the diagram is about the state of our economy, and these are the three possible states. And in the third section, the associated probabilities are mentioned. For example, for recession, the probability is 0.2. For a normal situation of the economy, the probability is 0.4. So you see the probabilities, they are the same for the first plant or the second plant, because we're talking about the same economy, and the chances of having boom will be the same no matter we are talking about first possibility of the plant or the second possibility of the plant. So we have the present value of net cash flow that we can calculate here. It is 5 million, and then we have 3 million, and then we have 1 million. These are the present values of the net cash flow. We know about the present value when we do the discounting, and we know that net cash flow is about the difference of the returns and the costs. So these are the final values after taking the difference and doing the discounting. So these are the three outcomes in these three scenarios of the economy. So we can multiply them and we can get the expected values now, because we have taken the probability weighted products. So 0.4 into 5 million will become 2 million, and in the same way we can consider the products here and the answers. Now these are in case of the three states of the economy, so we will take a vertical sum, in order to get the overall expected present value of the net cash flow. It is expected because we are considering these probabilities, and three values are there. So probability weighted average is calculated. The present value is there because the discounting is already done in this case, and net it is because these values are actually the differences of the returns and the costs. So it is now a net effect. Now when we take the vertical sum, we will get this value, and this is actually the return, and the plant cost is 2000. So when we subtract it, we get this value, which is the expected net present value. So now we can call it expected net present value because the plant cost is also deducted. Now we can save this for the first plant that is worth $2 million, and you can see the same process is done here. So you can do this simply by pausing the video and focusing on the given values, and you will see that the expected present value of net cash flow would be this, and this will be the plant cost. It is $1 million as we have borrowed it from there, and this is the expected net present value, which is the difference of the two, and it is equal to this, that is 12 lakhs or $1.2 million. So you can see that this project or this plant is more suitable because it is greater, that is 1.4 million as compared to 1.2 million. So even if the cost is greater, that is it is $2 million instead of $1 million, which is actually the half of it, the overall returns are greater in this case. So by making this Dcm tree, because you can see it looks like a tree where there is a main stem, and then from the stem we have two major branches, and then we have further twigs, and all these are giving us a kind of a tree. So this is the Dcm point where the Dcm should be made, and you can see this cut or cross, and it shows that this is not the most ideal option that we have. We have this as the most suitable option. So this is the interpretation of it. So it means that the larger plant is more suitable regardless of a higher cost. It will give us a greater net value. So these are the same things that we have understood. You can pause the video and read these. We have seen the benefits of calculating the expected value or expected profit, but in addition to profit, there can be another dimension that can help us to determine the decision making of the managerial economist, and that dimension is about the behavior towards risk of the managerial economist, because the behavior can be towards the utility driven from the profits that the firm will make. It is not just a monetary phenomenon, rather it is related with the utility that the manager can have by making certain levels of profits. So let us see how we can assess this. Basically, when it comes to the behavior towards risk, it is categorized in three categories. One is the risk averse behavior, other is the risk neutral behavior, and the third one is the risk preferring behavior. And usually what we see is that the managers or most of the human beings, they are risk averse. But it's not definitely a carving in a stone, because sometimes managers do prefer to take risks, but these are usually calculated risks. So let us assume that something which is more realistic, and we can see in our real life that people are more averse to the risk instead of being preferers of the risk or being neutral to the risk. So risk aversion is something that we can observe in most of the human beings, including the managerial economists. So and what we see is that they have a diminishing marginal utility in them for money. It can be understood with the help of this diagram, and also with the help of this line that suggests that if we double the amount of profits, it is not going to double the utility that we derive from it. When this happens, that is, the utility is not doubled when we double the profits or the amount of money that we have made. It means that the marginal utility of money is diminishing, definitely, because we are not getting as much of the utility as much as we have observed the increase in the monetary value of the profits. Marginal and extra utility is going to diminish. In this diagram, it is visible because money is plotted on x-axis and utility of money is plotted on y-axis. You can see that as the amount of money is increasing, utility of money is also increasing because it's a positively sloped line, but it is not increasing as it was increasing initially, and there is a increase at a decreasing rate. So that increase at a decreasing rate is basically showing the dimensional marginal utility for the money. As the individual is making more money, utility is not increasing that much, rather it is increasing at a declining rate. So how we can assess this quantitatively? Under such conditions, a manager will not undertake an investment project even though it has a positive expected profits if its expected utility is negative. So it means that not every time the expected profits are going to be the determining variable. Instead, the expected utility can also be a determinant depending upon the nature or the behavior of the individual or the managerial economist towards the risk. That is, the expected utility can be a determining variable. Let us see. Here again we are using a simple example where the states of nature are mentioned. States of nature are two in this case, that is, there can be success or there can be normal situation. We have probabilities, and probabilities are 0.4 and 0.6, and then we have monetary income or outcome, that is, there is a positive value of the outcome if there is success. If there is normal outcome or not an ideal situation, then there is a loss of $20,000. And with a positive value of the monetary outcome or the profits, the utility is positive, and with a negative value, that is a loss, there is a negative value of the associated utility. We can calculate the expected profit simply by multiplying these values with their probabilities, and we will get the weighted probability expected profits, and then we can take the sum, and in this case one is positive, other is negative, so their vertical sum will be like this. The answer will be $4,000. And then we talk about the expected utility, which is usually measured in utils. And in expected utility, you can see that there is a product of the probabilities and the expected the utils that they are going to get, that is minus 15. So minus 15 when multiplied with the probability will be minus 9. So now we take their sum in order to get the expected utility contrary to the expected profit that we calculated before. And here the sum is negative. So what you see here is that the expected profit is a positive value. However, the expected utility is a negative value. So a negative expected utility can be more appealing for the managerial economist in decision making, and he might not go for this investment because the expected utility is negative. Because as a human being, even a managerial economist will be concerned with the final thing that one is going to get from that, and that is the utility, not the profit, because that's a source of utility, the monetary means that we have. But the final thing that everyone is trying to withdraw, to draw from the monetary value, it is the utility. So if it is negative, the final thing will not be desirable. So you see that in addition to expected profits, the expected utility can also be a determining variable in terms of decision making. Here there is a small note that can help us. We can see that this is the monetary outcome, which is for 40,000. This is minus 20,000. And these associated utility values, they are smaller values. In this case it is 15, and in this case it is minus 15. So this is something that appears as a pattern, and sometimes it is also given in a mathematical form. The thing is that it can be large in number because of the monetary units, but these are utils, and units of utility, they are not likely to be this large. So they are going to be smaller values as compared to the monetary outcomes. And for example, another monetary outcome and its utility function is given, that if we take the square root of the profits or the monetary outcome, we will get the utility value. Here it is not so, because it's a negative value here, and taking its square root will not give us any value. It will give us a complex number. But here we are assuming another possibility. It is not this function, it is some other function. For example, if the profit is 121, the utility will be 11. If the profit is 9, the utility will be 3. So in this way, the relationship between the monetary outcome and the associated utility can be modeled in this function. And if we are given this function and the profit values, we can easily calculate the utility simply by using such sort of functions. So this is how we have understood the overall topic of risk analysis, and this is the steps that we did in expected profit, in standard deviation and coefficient of variation, and this is how we can conduct the risk analysis in the process of analysis by a managerial economist. I hope you have learned from it. You may give it a thumbs up. Thank you.